Welcome to the session on resistor color coding. Having seen what a resistor is and various types of resistors commercially available, in this video we will see how to find the value of a particular resistor. By now, you might have observed the different color bands painted on the resistor. Let's find out in this video how to find the value of the resistor from these color bands. Commercially available resistors can have either 4, 5 or 6 bands of colors painted on them. Depending upon the number of color bands, these resistors are known as either 4-band, 5-band or 6-band resistors. Let's start with 4-band resistors. If you see any 4-band resistor, you will find the 4 color bands painted over it. Out of these 4 bands, the first 2 bands defines the first 2 digits in the value of the resistor. The third band represents the multiplier and the fourth band defines the tolerance value for that particular resistor. Now, depending on the color of these color bands, the value of the resistor will change. Let's find out the relationship between the color and the value that is represented by that particular color. Here, this table represents or defines the relationship between the different colors and the values that are represented by that particular color. Now, the first 2 columns of the table represents the first 2 color bands of the resistor. Depending upon the color of these 2 color bands, the value of the resistor change. And the next 2 columns represents the multiplier and the tolerance values for different colors mentioned here. Now, as the color changes in the color bands of the resistor, the value of these parameters also change. Now, let's take an example and see clearly how to calculate the value of the resistor. Let me take a 4-band resistor in which the first color, green, represents the value 5 from the table. The next color, blue, represents the value 6. The third color, that is red, represents the multiplier which is taken from the table. And the fourth color represents the tolerance. Because it is colored in gold, we have to take the value plus or minus 5% from the table. Now, when you combine all these digits, you will get the value of the resistor. Let's combine and see the value. 6 multiplication factor, you have the value of the resistance as 5600 ohms or 5.6 kilo ohms plus or minus 5%. Now, if you don't have any color specified in the 4th band, which means you will have to consider the tolerance as plus or minus 20%, which is not mentioned in the table. Now, let's have a look at 5-band resistor. For a 5-band resistor, you have 5 color bands colored over it. Now, the first three color bands represents the first 3 digits in the value of the resistor. The 4th band represents the multiplier and the 5th band represents the tolerance. Now, this table represents the relationship between different colors and the values for different colors. The first 3 columns of the table represents the first 3 color bands of the resistor in a 5-band resistor. Depending upon the color of these 3 color bands, the value of the resistor changes. Likewise, you have multiplier and tolerance mentioned in the next 2 columns of the table. Now, depending on the color of these 2 bands, again 4th band and 5th band, the values of these parameters also change. Now, let's have a look at an example which clearly tells us how to calculate the value of a 5-band resistor. The first color, green, takes the value 5 from the table. The second color, blue, takes the value 6. The third color, black, takes the value 0 from the table. The fourth band takes the value 10 to the power of 2, as it is colored in red. It represents the value into 100. And the fifth band takes the value from the table. Because it is colored in gold, you will have to consider it as plus or minus 5%. That is the tolerance for this resistor. Now combine all the values 5, 6, 0, the 3 digits in the value, and the multiplication factor to get the value of the resistance as 56,000 ohms or 56 kilo ohms plus or minus 5%. Now, if you don't have any color specified in the fifth band, again, you have to consider the tolerance as plus or minus 20%. Now, let's move on to the 6-band resistor. As you can see here, the 6-band resistor has 6 color bands painted over it. The first 3 bands represents the first 3 digits in the value of the resistor. The 4th band represents the multiplier, as we have seen before. 5th band represents the tolerance, and the 6th new band represents the temperature coefficient for that particular resistor. Now moving on to the table, which represents the relationship between the different colors and the values for all these colors. You have first 3 columns represented for the first 3 color bands of the resistor. Depending on the color of these color bands, the value of the digits change. And the next 3 columns of the table is for multiplier, tolerance, and temperature coefficient. Again, depending on the color of these 4th, 5th, and 6th bands, the values of these parameters also change. Let's have a look at one example. We have taken a 6-band resistor, from which the green color, that is the first color, takes the value 5 again. Blue color takes the value 6. Black takes the value 0 from the table. Red takes the multiplication factor as into 100. And the 5th band, that is the tolerance band, takes the value plus or minus 5% because it is colored in gold. And the last band takes the value 15 ppm per degree Kelvin because it is colored in orange. Orange has the value as 15 ppm per degree Kelvin for temperature coefficient of that particular resistor. Now combining all these, you get the value of the resistor once again. The value of the resistor is 56,000 ohms or 56 kilo ohms plus or minus 5%, having the temperature coefficient as 15 ppm per degree Kelvin. Now again, if you don't have any color specified in the 5th band, you will have to consider the tolerance as plus or minus 20%. Hope you have understood how to calculate the value of various bands of resistors. This is all for now. Thank you for listening. Have a good day.